All right. So sorry about that. This is our first webinar, and we had a unforeseen slight issue, but I think we're up and rolling now. All right. So welcome to the 2025 Herpetology Collective Workshop, happening in conjunction with Happy Dragons. It's our first webinar for the Happy Dragons platform. Been doing this for years. It's usually a 6-hour workshop, but we're not going to be here for 6 hours. Took a lot of slides out, and I'm going to try and keep things moving. And we're shooting for, somewhere around a couple of hours. And I'll hang out as long as people are here. We'll have a Q&A at the end. And, I may not know all the answers to your questions. In fact, I'm proud to say I don't know. I think more people should be okay with saying I don't know instead of giving, guesses. I know that happens a lot on Facebook. So anyway, very casual. I'm in my truck at the wildlife refuge because I don't have reception to do live streams out at the rescue because it's way out in the country. So I drove into town. I'm in the truck, just because it's got all my stuff with me and whatnot. So point is, stop me anytime or, jump in with questions anytime. I'll answer them if I see them. My producer will let me know that they're there if I'm not seeing them. But the workshop is broken up into 5 segments, and I'll stop in between each segment to make sure y'all know you'll have an opportunity for questions. But if you're the type that would rather not break up the flow or you're nervous about asking questions, like that's what the Q&A at the end is for. So, stick around, ask anything you want, either about reptiles or amphibians or, about happy dragons or me or the rescue or whatever you want. I'm here for y'all. So let's see, on the next slide, we got our objectives. So I would like to, not as a slide, but just the whole way through, impart the importance of, getting out there, getting connected with nature. I know a lot of folks in the group, Dermatology, are captive keepers. And I know, all of us love nature, or at least say we do. But I think that a lot of us tend to get in our indoor routines and not get out in nature all that much or as much as we would like to. And we end up, leading kind of insular lives. And there's just fascinating drama unfolding a few feet away from you, right outside your door. If you're around where I live, you've got little male anoles battling for dominance for your fence or your wall outside. You've got predator-prey relationships going on, just so much. And we walk right by it, we don't notice it. And my goal kind of in life, my self-appointed mission is to help people take a step forward from wherever they are towards an appreciation and an understanding and a fascination with the natural world around them. And I use reptiles and amphibians as a vehicle for that because I'm most fascinated by those groups of animals. But if you're interested in insects or mammals or whatever, it doesn't matter. The point is find your passion and try and make time to pursue it, and not only get out in nature and observe it, but also try and learn more about it. Not only to learn the names of the organisms that live around you, but also, their role in the ecosystem and, just their natural history. And the more you learn about these animals is the more connected that you find yourself getting to them. And the more connected that you are to them is the more that you're going to work to preserve them and all of our natural heritage for, not only the earth's sake, but for future generations to be able to enjoy these fascinating little critters outside their door. Also, we're getting to a point as a planet and as the, dominant species on the planet and our, amount of habitat destruction and everything else that we do, that it doesn't matter who you are. We need you to care. We need you to get involved. We need you to love nature because we love the things we protect and preserve, the things that we love. We prioritize the things that we love. There's not enough minutes in the day. All of us, wish we could do more of this, that, and the other thing. But quite honestly, human nature is we make time for the things that we care about. And so I try and get folks to care about reptiles and amphibians. And, preserving their habitat is what it really comes down to, because that's how we preserve them, is by making sure they have clean, healthy, proper working, functioning ecosystems to live in and raise their own kids in, or, drop their own kids and keep on trucking and hope that the kids do okay. And anyway, and again, not necessarily as a slide or a segment, but I, would like to also impart why science is important to reptile and amphibian keepers. I think probably all of us know that just picking up a care sheet from the pet store isn't where it's at. You can't impart the multitude of subtleties that go into optimal husbandry from a single page or a short Google search, or, by asking people who may not have a great deal of experience, but, are friends and family or so forth. Even on Facebook groups, I'm not bashing Facebook groups. I'm certainly not bashing any in particular, but there is a lot of folklore husbandry out there. And by that, I mean things that we have strongly entrenched in the community that we believe to be true because everybody says it and they've been saying it for so long, that isn't actually based in science. And another way of putting that is isn't really based in sound principles and facts and so forth. An example would be learning about, if you get a little lizard from the steppe of Russia, you'd want to find out what the climate is where they live. You'd want to find out what the daily temperatures get to and what the nighttime temperatures get to, and, what kind of humidity levels do they live at, and, how arboreal are they? Meaning, do they like to climb? Would they rather be hiding under rocks? Do they like to burrow underneath the substrate? These are all things that you need to know, because if you're trying to make the animal happy and healthy, you want to reproduce all those conditions as closely as possible. We can never recreate nature in a bottle, but we can certainly try and work with it and point towards that and adapt our care to fit that as best as possible, instead of just, sticking them in a tank with a heat light and hoping for the best. So to me, that proper care comes from an understanding of the natural world, which means science, biology, zoology, herpetology, and learning how to do research and so forth. So Happy Dragons partnered with me and vice versa, partly to be the community manager, because I've, been managing communities for so long, but also to be the guy that, kind of inserts care and concern for the wild critters into the platform. We have a lot of experts that know a lot more about husbandry than me. I don't claim to be a husbandry expert. Now I've, cared for, gosh, Lord knows how many species over the years, and, more than just reptiles and amphibians. We have mammals and birds and all that kind of stuff at the rescue too. But I, maybe it's just humility. I don't think so. Don't consider myself an expert. I consider myself as knowledgeable as I've managed to be. But we've got some other people on the platform, Mariah Healy with Reptophiles and, so on and so forth, that, I would consider experts. So make sure you get plugged into the platform. So let's see. I think that's the gist of this one. Let's skip to the next. And we have the segments that we're going to go through: diversity and classification, biology, physiology, reproduction, natural history, ecology and distribution, conservation, and observation. And then moving on, a lot of you have been asking, what is Happy Dragons? What is this new platform that I've been dropping, hints about and stuff? It's a platform for you, particularly, herpetology members. I mean, we've fashioned it for the herpetology community. Some of you may have seen that we've had polls and we've had a focus group that we assembled from the members there, and we're going to continue doing that. The point is, we're creating a platform that's an alternative to Facebook in many ways. We have, community forum where we can be doing our discussions and posting, our critters and questions and general discussion, just kind of hanging out like we do in the group now, so on and so forth. But we've added a lot to that. We've been, behind the scenes I've been on board for months, and, there's people that have been on board for longer putting this together, and it's really exciting. I've had a lot of companies reach out to me over the years because I've, done so many TV interviews and, published author and all that kind of thing. I've turned everybody down repeatedly, from whether it's reality shows or wanting me to be a staff writer or, you name it, because everybody either, if I'm being honest, seemed to just be out for the money, or they were wanting sensationalism, which is not my jam. Uh, or for one reason or another, it just seemed like a bad fit. They either wanted me to do something in a box that wasn't really a box I was comfortable in. But Happy Dragon came along, and guys, I got to tell you, this is a really exciting initiative. I've told you about the experts. We're going to be putting out these webinars routinely. We've got again, the community forum. That one of the big differences between the new forum and Herpetology is Herpetology doesn't allow husbandry discussion because of all those subtleties I mentioned earlier, and because of the rampant misinformation on Facebook, and because we only have a few people to herd 420,000 cats, and we don't have time to watch every comment on every thread. But this new platform, we will be able to. And what's more, subscribers, which is very affordable. Let's skip to the next slide here. It might have a little bit more. Like I've been saying, whether you're a beginner or experienced, we've got stuff there. I mean, I know a lot of folks feel like they've been doing it for a long time and already know everything they need to know, and maybe you do, but maybe you don't. And there's people there that really have a good lot on science-based husbandry, that are looking, they're breeders, but they're not just breeding to make money. They're breeding because they're viewing a long-term, past their lifetime, multi-generational flow of proper development and husbandry, and captive care of these species. I mean, they're looking 100 years down the road with the things that they're doing, and it's a fully different mindset than I've found other places. Sorry, motorcycles going by. What do we got on the next screen here? We got... Now, right now, it's a bit split up. We have the website with the store. We've got Discord server where the conversations are happening. And we also have the Patreon. The Patreon not only unlocks a lot of extra benefits, like personalized year-long, multi-step care plan to improve husbandry, but a lot of other things. Some of these webinars will be, for the subscribers. And for those of you that are following me, the lion's share of your Patreon goes to me, and where my money goes. It goes to support Learn and feed all these critters and stuff at the rescue. So for those of you, there's a lot of you that already have monthly donations going to Learn and stuff. You're welcome to turn those off and switch them over to Patreon here and get the benefits of the Happy Dragon platform for the donations that you're already making. And for those of you, that haven't yet, come over. You can dip your toe in the water on Discord for free. There's a lot of stuff that we're starting with, but also adding, like these webinars, and $9 a month, which is less than any of the subscription services I know are used, unlocks all of that. And not only that, again, you're helping me to feed and rehabilitate and rescue critters. So, I mean, you got good coming and going from, jumping into this. Moving on. A bullet point of these benefits is live webinars by Project Herpetology and other reptile experts, Q&A channels. There's specific wildlife channels, expert channels, including Ask a Wildlife Expert, and, Ask a Bearded Dragon Expert, so on and so forth. You can get answers from people that have actually been vetted and know what they're talking about, rather than going to maybe a Facebook group for that species and hoping that you're getting good advice there. We got online courses. Subscribers get my certified herpetological guide course free. So that's a pretty exciting benefit for that $9 a month. And we have other courses that are in the works that are going to be uploaded here real shortly. Interactive content. We have early access to breeder listings for subscribers and discounts on the store. I mean, you can get back that $9 a month just from the discounts because there's a lot of good stuff there. And everything on the store is, again, vetted. We're not about, hey, let's just add some more people to the store. We're, asking who are the guys that you really want to be getting stuff from? Who are the women that are out there putting in the extra time? Who are the people that are breeding ethically and conducting business respectfully and responsibly the way businesses should be doing it? And those are the people that we're reaching out to and adding. So it's just all very exciting. This is why I chose to partner with him. It's this kind of stuff. It's just exciting to me. I could talk all day about it, but I'm not trying to talk all day about it. So moving on. Next few webinars is, of course, today, Introduction to Herpetology. We have gradients, which is super important. Gradients. All right. Hope you're still with us. That's some more of those technical difficulties. So we got, we've already got workshop scheduled for the next month, every week going on here. A lot to see and do once you're there. Moving on. All right, who am I? Several of you know me, but if you're going to be listening to me for, another hour and a half or two, and you don't know me, just a brief few bullet points. I'm a Louisiana master naturalist. I've been a wildlife rehabilitator for years. I'm the author of the book, A Primer on Reptiles and Amphibians, which I'm proud to say has been out 5 years, and it hasn't received a single suggestion for a correction of any information provided there. It was peer reviewed by multiple PhDs. It's got nothing but positive reviews all over the internet, including scientific reviews. So check that out. You can get a free PDF on the website. We'll try and drop the link in the comments afterwards on the video here. I'm the editor-in-chief of an online publication called The Natural World that teaches people mainly about reptiles and amphibians, but other topics as well, just getting people more connected with nature in general. I'm the founder of the largest family-friendly reptile and amphibian network of, social groups and such. Y'all are probably familiar with Herpetology. I'm the president of Louisiana Exotic Animal Resource Network, aka LEARN. Been running, the rescue and rehab center for years. We built this new facility back in 2016. It's on 12 acres with 5,000 plus square foot of indoor space. It's it's not a, out of my garage type of deal. I'm the founder of the Herpetology Collective. The Herpetology Collective is the educational arm. It used to be part of LEARN also, but we kind of divided things. So LEARN is just focused on the critters, and the Herpetology Collective is focused on the public education and outreach and so forth. And I'm the 2018 recipient of the Joseph Laszlo Memorial Award, which is given to people that are basically doing exciting things in herpetology. And I was very honored by it. I mean, it's a big deal. It's the largest running herpetological symposium on the planet, the IHS is. So again, I don't call myself an expert in anything. I do say that I'm passionate about learning and passionate about sharing that knowledge. So I think that's why they chose me for that. So any other questions, you can Google me or Google Learn or ask them in the comments, so forth. But just wanted you to have some idea of who it is that you're learning from. Moving on. So here's the workshop. Herpetology. What is herpetology? It's the study of reptiles, which that word comes from creeping in Latin, and then amphibians, which is a double life, start as tadpoles, metamorph into something else. Despite us always saying reptiles and amphibians or saying herps and lumping them together in our speech, they're not necessarily all that closely related besides being tetrapods. Tetrapods, if you want a vocabulary word, is, critters with four limbs. And I know a lot of people are going to say, wait, a lot of lizards have 2 or 0 limbs and snakes have 0 limbs. But, from a phylogenetic perspective, an evolutionary perspective, that's the group that they came from and are still in, even if they have lost those legs over time. So they're grouped and studied together, again, in our own minds and stuff. I think a lot of the reason for that is just that the same people that like reptiles tend to like amphibians and vice versa. Uh, but they do have quite a few similarities, which are coming up here on the next slide. Getting into it, diversity and classification. We have, and I don't know that I have to read through all of this, but these are just some of the things that came to my mind about why reptiles and amphibians are so fascinating. They inhabit every continent except Antarctica. They inhabit land, water, oceans, mountaintops down to underground. There's ones that are active at all kinds of different times of the day. Some can go months and even years without eating. Some have great sight, some are blind. I mean, just screenshot this and read through it later. But the point is, you've got critters that walk, critters that jump, critters that roll, concertina motion, sand swimming, herbivores, carnivores. They run the whole spectrum of every spectrum, and you could spend your whole life and still die with only a thimbleful of what there is to know about them. So it's a field of study that never gets old, or it doesn't have to. You're never going to run out of things to learn about reptiles and amphibians and be fascinated about them. So that's why it's so easy for me to talk for a couple hours, as long as somebody will let me, about how fascinating they are, and that's what we're doing here. But I don't want to read every bullet word for word, because y'all are would probably get bored if I start just reading to you. So moving on, I like to tell the people at my local workshop, if some of them are still nervous about snakes and stuff, I tell them at least, the ones around here don't fly. Because, paradise tree snakes are a good example, and the Cool's flying gecko is another. And this is a little screenshot I took off the internet of a sign that says the door of the balcony has been locked to ensure your safety. Please close the window at night to prevent flying reptiles, at a Via International Hotel over in Asia. Now, I'll let you know a secret that it's really referring to mosquitoes, and it was a poor translation, but still, it could have been. I would have had a hard time not taking that sign home if I came across it. So a little bit of levity there, but moving on. I just love this picture. I would. This is a bucket list for me, is to go to the wash area and find a 8-foot Komodo sleeping it off on the cool tile floor. I would just love to experience that, but I hadn't yet. But I got this picture at least. So there's some parts of the world where you get to see that kind of stuff, and I envy those that are able to travel there. So, all right, I mentioned similarities. It's the similarities and differences list that I've got here was actually harder than I thought it was going to be to come up with, because there's so many exceptions for everything with reptiles and amphibians that if you try to say they're all like this or they're not alike because of this, the more you learn, you're like, wait, but there's these, ones over here that are, and it gets tricky. But what I was able to come up with is they're all ectothermic, meaning they regulate their internal body temperature through behavior rather than internal mechanisms that are generating heat and cooling them off. They all have spinal cords. They all go through ecdysis, shedding. Many of them in both groups, reptiles and amphibians, can change their skin color either at will or that changes because of temperature and other factors. There are a lot of animals in both groups that have a high visual acuity, meaning they can see well even at a distance. And they have a lot of similar defensive traits, namely, primarily you got camouflage, biting, inflating to look larger, or if they're not inflating, coils like you see corn snakes, pictures of floating around, making coils out of their body so that, it looks larger overall, even if their body itself isn't puffing up. But the point is looking more threatening and harder to eat. Uh, there are reptiles and amphibians that exhibit autotomy, and we'll talk a bit more about that later. And mimicry. A lot of people misunderstand mimicry. They think that, it's something that the animals are doing, like from an evolutionary perspective, a milk snake looking like a coral snake. I mean, he didn't do that on purpose. He doesn't even know that that's the case. He just looks like himself as far as he's concerned. But, natural selection has produced ones that are able to mimic that extra defense mechanism of the venomous, snakes that animals have learned to stay away from. And I just like to point out that, oftentimes when you hear people talking about mimicry, they sound like they think it's intentional, and it's not. It's just how nature works. Then on the next slide, we have the differences. And again, this was, kind of challenging to come up with like the similarities, but the ones I came to were reptiles are amniotes, amphibians are anamniotes. And I'm just going to put a pin in that because we'll come back to it. Reptiles don't undergo metamorphosis. The young look like a smaller version of the adults. Reptiles breathe through their lungs, and that's opposed to what you find in many amphibians, which is cutaneous respiration. The get water and air for some of them through their skin. Reptiles can turn their heads. Amphibians, salamanders, and frogs, I don't know if you ever thought about it, they don't really have necks. If they need to see something over here, they have to turn their body over there, whereas lizards and, snakes and stuff and turtles can look back and forth. Reptiles have scales, aka scutes. Well, not aka, but scales or scutes, sometimes both. Amphibians have permeable, soft skin. Reptiles tend to exhibit longer lifespans. Some reptiles possess loreal pits, which, heat sensing pits, such as vipers and, some pythons and such, which are absent in amphibians. But amphibians, many use what's called a lateral line. It's a sensitive part of their body that detects minute changes and vibrations in, like the water around them, that makes it easier to hone in on prey, even in murky water when they can't easily or be seen at all. And those are the ones I could come up with. I'd love if some people, have some ideas on things I could add to that list. I think you might find it's harder than you, thought it was going to be to come up with anything. There's a bunch more that I tried to add and, realized I couldn't. But if you can think of them, please add them in the comments on YouTube. So moving on. Okay, the bane of my life sometimes running reptile groups. Common names. Many, if not most, reptiles have a variety of names in different regions. That's called colloquial names. A cottonmouth, if you go to Wikipedia and look down for alternate names, I think the last time I checked, there was like 32 of them or something. And that's just for one animal, and it's not even an all-inclusive list. So, and you've got, hognoses being called spread natters by a lot of folks. Rat snakes are called chicken snakes. A common name doesn't have to be just the one that you see in a field guide. Common names are anything that, they're commonly called. So, I might be in the deep woods of Mississippi and, call a hognose a spread natter or a spread natter. And if the person that I'm talking to knows what I'm talking about automatically without me having to explain it, that's the purpose of language. The idea that you're trying to impart is being successfully imparted. So these colloquial names are valid. There's not somebody that is the final arbiter either on Facebook or somewhere else that can say, hey, that's an invalid name. You shouldn't call them that because of such and such. No, people, can have their different regional varieties all over, and that's wonderful and beautiful, and we should appreciate that. However, we should recognize that it has, limitations and consequences if If I'm here in Louisiana and somebody says that there's a loggerhead that lives in that pond over there, well, if I'm used to official common names, I'm thinking a loggerhead sea turtle. And I'm thinking that this guy is full of baloney, because how is a sea turtle living in this little half-acre pond over here? But if you're, from this area, you learn that they're talking about snapping turtles because they have big old heads, and for some reason that got them the name loggerhead from country folk around here. So it can generate, confusion like that. Not only if someone has just never heard the term before, but also because so many of these names have an overlap, and you might not know that you're talking to somebody and you know what you're talking about, but you've used this colloquial name and they're picturing something different entirely, and the people can leave the conversation not even knowing that they weren't having the same conversation while they were having it. So it can get real confusing. That's why, in our ID group, which is paused at the moment, we use the standardized common names, which, it doesn't mean that they're the only right ones, but it does mean that we need some kind of standard, because how else are you going to produce a field guide if you don't have anything to call them? So, there's a council that chooses the best name that they can. There's never going to be a name that makes everybody happy for a lot of these animals. You're going to have old school herpetologists saying, well, I grew up calling them this for the past 40 years, and how are these people going to decide that, this is now a northern cottonmouth? And, just, it can produce arguments as well, but nonetheless, it helps reduce confusion as a net gain. So that's why you see every, reputable scientific organization adhering to this list, is because it helps reduce confusion. So it's good to know what the quote unquote official common names are. And usually the best way to find that is just crack open a field guide. So I recommend, though, for people to familiarize themselves with scientific names. And I know a lot of people are like, oh gosh, but that's so boring. I really don't want to take my time doing that. It's not. It's not boring. You were learning it from the wrong person if you think it's boring, because it, imparts so much useful information, which, let's see, I think we got some more about it on the next screen here. So scientific names is, that's taxonomy. What that is the ordering of organisms into groups that share similar characteristics. So you have a specific name for each unique species. And each unique name at whatever level is a taxon. The plural is taxa. So if you're referring to multiple scientific names, you call those taxa. Whereas if you're just talking about one name, you would call that a taxon. So it's dynamic. It changes. A lot of that, it's happening a lot more nowadays than it used to. And a lot of the reason for that is we have a lot more access to scientific tools and techniques than we used to have. So there's a pendulum over the past, however many odd years. People have, kind of been so excited by these new techniques that they're racing to change everything over to line up with this new information. But there's a lot of people with very valid concerns that, we're placing a little bit too much importance on differences that are so minute. If the differences that you're looking at can only be detected in a lab, maybe that's not enough of a reason to redo all of the, names and methods of organizing them that we've been used to for so long. So there's certainly a balance that needs to be struck, because we don't want to ignore either end of the spectrum, but, we want to create the best balance that we can between the two, and it's tricky. And that's why we have that SSAR council that I mentioned on the last slide there. We have experts in the field that sit around and debate this stuff, and they do their best to be conservative, but every change is going to upset somebody. And we're starting, I think, to swing the pendulum back to where we're not just changing everything quite so easily on a whim like we were. But nonetheless, the point is, be used to the fact that once you start learning about the hierarchy and all these different taxa, that it's not set in stone. It's they're all hypotheses, is what they are. They are a scientific name is a hypothesis based on the best information that we have at the time. the hypothesis that this species is closely related but not the same as these other animals that look a lot like them, or vice versa. Whatever the hypothesis is, all of the different reasons that we group or separate the animals is the best that we know right now. And that science is a moving target. That's always going to change, whether it's about taxonomy or other stuff. I mean, we're constantly learning more. So we're constantly having to update and adapt what we know and our references and our names for things, and, how we call this, that, and the other species. And it's that's a lot of why it's not boring. You're not looking at this dry thing that is only useful to professors and that you only need to learn to pass a test or whatever. You're staying abreast of what we know about this remarkable multi-layered rainbow of relationships that go deeper than our mind can conceive. I mean, even if you're not talking about the whole world, even if you're just talking about the ecosystem you live in, there is more going on there than you can learn in your lifetime, even if that's all that you were focused on learning. And taxonomy is our way of trying to, make sense of this stuff and categorize it and figure out the relationship between all these things. So, uh, I'm not going to geek out about taxonomy all day, but I do think it needs a little bit of defending. I mean, the reason I like reptiles and amphibians is not the only reason, but a good part of the reason is they're an underdog. People kill snakes, people dislike creeping things, and they need advocates. They need somebody that cares about them, that says, hey, they are cool, they are fascinating, they are fun. And I think all of y'all share that view. And taxonomy is kind of an underdog in the science world. There's a lot of people that, want to ignore it or toss it aside or never get around to learning about it. And I think that's unjustified also. I think that, every name says something. Uh, like the tegu, the red tegus, their scientific name, I don't know how best to pronounce it, but Tupinambus teguexin, means the fruit-eating lizard of the Tupinambi people down South America. I mean, that's a cool descriptor. And, that's a cool thing to know just by learning the scientific name. You're like, oh, I didn't know he ate fruit. I didn't know the Tupinambi people used to live in that region. I mean, you're constantly learning stuff when you're learning about it. So, all right. I'll cut it off there. I don't want to do taxonomy all day because some of y'all go to sleep. So, but I think you get the gist. Moving on. We're not going to go deep into this, but this is just an example of a tree of life, so to speak. This is one way of doing the diagram, and there isn't one set in stone. This is the tree of life. Again, this is still taxonomic type stuff, so it's constantly changing. But you will see that it's got birds sprouting out from the reptile part of the tree. That's kind of what you hear when you hear these people talking about birds being reptiles. It's not exactly that birds are reptiles, but they're all coming from the same part of the tree, so to speak. But you know, Google some of these type of trees of life and spend some time with them if you want to learn more about these relationships. Moving on. Here's another simpler way of putting it. And again, you've got the birds grouped in with reptiles, and you got just when we talk about categorizing things, these are ways of diagramming it out. And I always like to point out the Tuatara when we're talking about these orders of reptiles. If you look closely here under the little brackets that have reptiles, birds, crocodilians, lizards and snakes, turtles, we know those groups. Those are big groups. But then there's Tuatara. That's one or maybe two, depending on which taxonomy view you ascribe to or subscribe to about them. One, maybe two species is a whole order. There's a picture of them on the screen there. They look like lizards. They're not lizards. They're so different than lizards that they are in a whole different order, which, from a taxonomic perspective is kind of like they're as different from lizards as lizards are from turtles. It's a little bit of an overstatement, but it gives you an idea. They have three rows of teeth between their upper and lower jaws, which other reptiles don't. And I don't need to geek out about Tuatara all day, but since they deserve their own order, I always like to give them a special mention. So let's see, we can move on. We got, I wanted to update this last night. I've been meaning to update it for a while, but I always
I'm Mr. ADHD, as a bunch of y'all know. I work with deadlines. I was up past midnight, getting this show ready, and I just ran out of steam before I could update it. So anyway, these are 2018 figures. This is, different now, but as of 6 years ago, we had 7 years going on now. 10,711 reptile species that we knew, and 7,838 amphibian species that we knew of. And while those are fun numbers to know, I like to, point out that we can look at where most of these numbers are. Like you look at crocodilians, there's only 24 species of those in the whole world. So, I mean, you could learn about all the crocodilians out there pretty easily. Not everything there is to know about them, but it's only 24 species. So it it also not only means that it's easy to learn them all, but it means that that's a limited amount of biodiversity. That means every species is important anyway. But when you've got something like this where there's only 24 species in the whole world, then that starts to make any species that disappears, feel like a little bit more of a tragedy. Uh, so you got the tuatars, one species I mentioned, which again, that's the best example of that. If we were to lose tuatara, we wouldn't just be losing a species; we'd be losing a whole order of animals on the planet. Uh, and y'all can see the numbers for yourself, or screenshot it and put it in your pocket for later. Or if you're like me and the rest of the ADHD crew, screenshot it and never look at it again. But anyway, uh, I like to put those out there and highlight, take a minute to look at the where those numbers lie. The biggest ones are frogs and amphibians and lizards and reptiles. So there's a lot of diversity there. I mean, a lot of people don't realize how many thousands of frogs there are. I mean, you don't know all the frogs out there. I mean, you may have thought, because you see the same ones all the time on Facebook or whatever, that you're familiar with the uh, majority of them, but you're probably not. There's a lot of them out there. Same goes for lizards and, also for snakes, but less so for these others. And we'll skip ahead here. You don't have to learn all this biology stuff. This is just the cover for this section, but this means that we have a new section coming up. And I said that we were going to stop and make sure that there's time for anybody to ask questions. Let me look over here and see if there's any questions yet in the YouTube chat. Welcome to our live show. It says, Gary joined the Discord. Good job. Wayne Abeats. Sorry, I'm butchering that name. I'm glad you made it too. And Carrie says, and those who glide, probably talking about the Cool's flying gecko and the paradise tree snake. And yes, somebody learned something. The caffeinated lizard. Can't say I've ever realized I've never seen a frog turn its head. Yeah, right? You don't think about these things until you stop and think about them. So anyway, I'm glad y'all are picking up some tidbits. Feel free to ask more questions there. I'll stop in between each segment like I've been and keep doing that. All right, so I mentioned autotomy earlier, but didn't talk about what it was. It's the scientific term for animals dropping, well, like the lizards dropping their tail. That's autotomy. Some things about autotomy is, well, like it's a good defense mechanism. The picture that's on screen here is of used to be called ground skink. The current official quote unquote common name is little brown skink, because herpetologists are just imaginative like that. It's a small brown skink, so they called it a little brown skink, kind of like a rough green snake and so forth. But that aside, when they drop their tail, it just flops and jumps and goes all over the place. So it's pretty hard for a bird or some other predator that sees that not to be looking at that, either to be like, whoa, what the hell is that? Or to say, oh, there's a, great morsel that I want to snap up. Either way, if their attention is on that, wriggling, flopping around tail, the lizard's got time to hightail it out of there. It's a very effective defense mechanism. So the tail regenerates over usually a period of weeks. The new section, a lot of people don't know, contains cartilage rather than bone, where the bone structure was before. It's a cartilaginous structure that's created when it regrows. There's often a difference in appearance that can be stark. I've seen a lot of for example, green anoles with dark brown or black tails where it regrew instead of their most of the time green body. Other times it can be rather subtle, but it's usually there to some degree. Now there's an increased predation risk during that regrowth time uh, because they don't have that toolkit, that tool in their kit anymore. They can't drop a tail again if they haven't regrown it yet to distract the animal. And so we've actually noticed, like this little brown skink and other, small lizard species like that, they seem to know that because you'll see them sticking closer to the leaves or sticking closer to the wood piles during that time of regrowth, because I believe because they're fully aware that they can't do that trick again for a while, so they're being more careful. Uh, so it happens, a lot of people don't realize this also, along vertebral cleavage planes. It's not breaking off between the vertebra. The vertebrae themselves have kind of a built-in fracture point. And when we pull a lizard's tail off, it's largely not us actually pulling it off. There are these powerful muscle contractions that happen around that fracture plane in the vertebra that split off that part of the tail. The lizard is doing it. That's why it's called autotomy, because autotomy means, self excise of that body part. And there's a few snakes that practice it. It's called a pseudo-autotomy because it doesn't grow back. But in any event, take care to avoid causing this. If you're going to pick up animals that do this, whether it's a pet or a wild animal, try to be extra careful. Gently cup your hand around the whole animal, and if you pick them up, pick up, support them by their body between their front and back legs, gently, of course. But if you're not very good yet at catching lizards and you're going to try, don't clap your hand down on their tail and make them lose the tail, because not only is it rude, it reduces that predation deterrent or trick there. It's going to be harder for that animal to survive for a few weeks because of you missing and grabbing the wrong part. So either wait until you can be shown by somebody else, or just wait until your skill level improves. If you find yourself pulling a lizard's tail off, like that's a fail. And you want to take care to avoid it for these reasons. But I could talk about it more, but this is just another example of the fascinating adaptations and stuff. And if we're talking about captives, these things that we're learning about wild animals also apply to a lot of captive species. So those of you that have a primary interest or have had a primary interest in captives, even though I'm framing our discussion today as being all about wild critters for the most part, I hope and believe that you are seeing the ways that you can apply this knowledge to your captive care. And the more you understand about the biology of these animals that you have, is the more that you can provide well for them. Again, like I said earlier. So shedding, ecdysis is the scientific name for that. Reptiles and amphibians both shed their skin. We often don't see, like, if you have a pet frog and you hadn't had it for a while, you may not think that he's shed yet because you didn't see it. But then one day you walk in and the frog's doing this and peeling the skin off of everywhere he can reach and shoving it into his mouth and eating it and not leaving it around sitting somewhere. It's pretty comical to watch. But it happens in both reptiles and amphibians, even though we only usually think of it happening to snakes and lizards. It's usually a function of growth, but it can also be a response to skin issues, lacerations, parasites, so forth. If they've got, something going on with their skin that's an irritant, they can't go to the drugstore and do anything about it. Their recourse is to shed their skin, and through that process, either get rid of the mites, for example, or, give a fresh start to whatever wound or condition is going on. It happens, since it's largely a function of growth. It happens more often when they're young, and like seasonally when they're eating more and growing more. Reptiles never stop growing. Herps, in general, never stop growing, but they grow, exponentially slower the older they get. So that's why you continue to see shedding throughout their lifetime, even though you see them every day, so you may not notice that they're still growing a bit, but they are. Many of these animals ingest their skin. In fact, Sicilian species, the young feed off of their parents' skin in their little neonate nest. They also found recently that at least one Sicilian species, some of y'all may not know of Sicilians. Sicilians are a kind of amphibian, legless. They're segmented. I think we'll talk about them a little more later. But anyway, they're another group of amphibians along with frogs and salamanders. Uh, so many of these animals, they eat their skin, which to us probably, a lot of us might seem gross, but it's utility. In the wild, you don't pass up a free meal, and if you got something organic and edible right there in front of you, hey, hey. And I found online that it seems like a whole lot of people think that you can count the rings on a turtle's back, for example, and that's how many years old they are. Or different people have different, you know, ways of guesstimating. And there are, some biologists can get a decent feel, but it's not an exact science. It's not like you count the rings and divide it by a certain number or something, and that's for sure how old they are, because it happens from growth and it happens from eating. The more successful this animal is at foraging and hunting and so forth, depending on the species, is the faster they're going to grow, which means it's the faster that you're going to see rings that are evidence of that growth. And it's not necessarily tied to number of years. It's tied to that animal's growth, which can vary just like with humans, along with individuals, even in the same habitat as others of the same species. So there's too much variation to come up with a simplistic method like that. And I just mention it because I see it so often online. And same thing with rattlesnake. A rattlesnake gains a new rattle each time it sheds, but it's very rare for an old large snake to still have all of its tail because it gets caught on things and broken off and so forth. You can tell when they do have their tail. You're usually going to see this in youngsters. They're going to have a button on the end, which looks different than the rest of it. The rest, even if the broken off part isn't there for you to look at anymore, it has an open area, at the end that used to have another segment in it, but the button isn't like that. It's closed up because it was the first one. Uh, so you can tell if they have their whole tail, but you can't, like say that rattlesnake is 16 years old because you counted those segments because they're based on shed cycles, not, the calendar. So anyway, that's a little bit about shedding there. Some of it I hope maybe y'all hadn't heard before, or if you had heard all that before, then make sure you send me a friend request because I like being around people that are as geeky as I am. But moving on, we got sexual dimorphism, and I think a bunch of y'all may know that term, but that's the external differences, things you can see generally between the sexes of the same species. In other words, the way males and females look different that you can point to and say, hey, that's a male or a female without probing them or doing something else that you can't, going where you can't see to find out that information. So it's very common in nature. Humans are sexually dimorphic, with their sexual organs and so forth. Not all reptiles are species are sexually dimorphic, and some are there, but very subtle. I remember reading a scientific study about those little brown skinks, used to be ground skinks, and it turns out that the males have slightly larger heads and a little bit different shape to them than the females, but it's the type of thing that you had to, like this researcher, pick up hundreds of them and measure them with a caliper. And after he had done it with hundreds of them, he could probably look at one pretty easily without measuring it and say, hey, that's probably almost certainly a male, or it's probably a female. But it's not the type of thing a layperson, like, you're not going to just see a lizard and say, you see how big his head is? That's because it's a male. Because to a novice, they're all going to look the same. So that's what I mean by subtle differences. There's more sexual dimorphism in species than a lot of us realize, because those differences can be so subtle that you've got to be intimately familiar with them to know it, but they're still there. So, and this can be head shape, tail length, claw length, eye color, skin color, all kinds of things. But it's an easy way to look smart to your friends if you learn some of these characteristics, because you can be walking in the woods and say, that's a male broadhead skink, or so forth, without even picking them up. And people are like, oh, wow, you're an expert. Uh, but anyway, fun party trick. Moving on. Here's a common example that comes up a lot. Uh, Now, there's not a rule that applies to all turtles. There's not. There are guidelines that apply to a lot of turtles, such as males having the concave plastron, because it helps when they're mounting the female from them not falling off. But and there's some like redfoot tortoises that really you can tell. I mean, it doesn't take somebody that's looked at hundreds of them to be able to tell a male from a female when you're talking about something like a redfoot. But anyway, it's a good one to know. If you see a very concave plastron, you're probably looking at a male. If you see a plastron that doesn't look all that concave, it probably means that you're looking at a female, but you could be looking at a male that's just not all that concave. The notch in their anal scutes, the V notch above their tail is shaped differently. You can see that for the females, it's deeper, which allows more space for the egg to come out when they're laying eggs, obviously. You tend to see, and you can see it if you look close in this picture, the male's cloaca, the single opening through which wastes are deposited and eggs are laid in the females and so forth, is farther out on males than it is on females, for two semi-obvious reasons. One is, if you're a female and you're pushing an egg out, you want to get that thing out where your tail is still thick. You don't want to have to push it through more of your tail before it comes out. So it's a good thing. And then for the males, when they're mounted, they've got to reach that tail all the way down around to get to the female's cloaca, and so all the more space you can get is helpful. I'd like to mention these bits of reasoning because it helps us remember the differences, but it also helps us make sense of why these things are the way they are, and it builds that intimate familiarity that I talk about that brings us closer to nature. Is picking up these little tidbits along the way, more than just the basic fact of cloaca distance. Here's why it's useful. So I say that not only to say that I hope y'all are finding the extra depth of information useful, but also, if you are, try and make it a habit to be adding this stuff in when you're teaching others, because that's how we draw them into the fold. When we can share this understanding and passion, these animals start to be fascinating to others as well. But anyway, in many, not all species, females tend to be larger. And then in sliders, because that's a common reptile in the pet trade, the pond sliders, meaning yellow belly sliders, red-eared sliders, so forth, are a great example of that. The males have longer foreclaws, like ridiculously, comically Edward Scissorhands longer. And if you've ever watched them either in a captive environment where they have enough room and are healthy enough to be displaying natural behaviors, or if you're walking along a creek or something and paying attention and looking down at what the little critters in the water are doing, the males come up around the females and they do this little dance in their face, which I don't know if anybody has a solid reason, how they started doing that and, what they get out of it, but it's certainly fun and interesting to watch. And that, that's the only reason I can see for those long nails, is so that they can do their little Edward Scissorhands dance. It doesn't seem to, I mean, they're not that great for digging. I mean, they look like the ladies with the long nails when they're trying to type on the computer, as they're checking you out or something. It's not making life easier. But it sure is good when you're trying to do the dance. But that's a difference that you can see from a distance, not a long distance, but if you're close enough to get a good look at them out there on a log before they drop off of it, it's something that you can see from a distance. So those are a few tips to pick up, and all of that is what I'm talking about when we use the term sexual dimorphism. So moving on. Hemipenes. So a lot of people say that snakes and lizards have two penises. Technically, it's one organ that's bilobed, meaning it's two halves of the same organ rather than two whole organs, but that's fine. You can still say they have two penises. I'm just giving you the tech side of it. So they don't use them for urination. A lot of novices think that because people use penises, you know why. I don't have to explain. They are erectile with lymph fluid. Like with mammals, humans, erections happen because of blood flow, and the reptiles, it's lymph fluid, a little bit different. Fertilization can take place through either side, which has a few benefits. It allows the males to copulate from either side of the female, whichever one they happen to get over there and be on. But also, they've found that both sides are fed with semen separately. So the point is, they can go once and they're ready to go again right away. They don't have a recharge period, uh, which the benefit to that in the wild is, mating season, you may only see two females all year for some species, particularly like desert species, and so forth. And if you see a couple of females, you might see them in the same day. And so the ability to take advantage of both of those opportunities is doubling your, reproduction chances. So it's a pretty handy thing. There's a lot of jokes to be made there. I'm not going to make any of them, but I think y'all can probably, think of them yourself. So bulges are often visible. More jokes there, I suppose. The point is, you can often look, and there's a diagram here. If you look closely, you can see the difference between the leopard gecko's tail here between a male and a female. There's the other arrow on the male, which is on the left, is the femoral pores. That's another thing that a lot of people look for to sex that species. That can be kind of hard to see sometimes, but that's a little bit clearer picture. Anyway, and the hemipenes are a myriad of shapes. There's a lot of different shapes, and they found, not too surprisingly, that those shapes correspond with the female's organs, and how they kind of lock together. I'll never forget. I want to say 9, and came up along this brush pile where a bunch of canebrakes, aka timber rattlesnakes, Rotellosauras, were mating. I forget how many. I saw like 8 of them. But we disturbed them, and one of the males separated from the female that he was mating with, and I saw his hemipenes, and it looked like a fleshy sweet gum ball. And my little 9-year-old mind didn't know what to do with that. And I, still don't know what to do with it besides just be fascinated and in awe of it. But I wasn't expecting to see that day, let me tell you. But that's not the only shape. You could learn about different hemipene shapes for quite a while, and I mean, there's jokes there, but it's an interesting field of study because, like I said about the being ready to copulate immediately afterwards, that gives us a better understanding of their survival mechanisms and techniques, and the more that we know about them is the more we love them. I mean, you can't, in my opinion, learn a substantial amount about reptiles and amphibians without loving them. And stuff like this is just adding more depth to it. So anyway, moving on. Oh, we're not going to go into this all day, but we have to cover it because it's comes with the gig. So this is a bit of an oversimplification, but venomous versus poisonous. Poison is ingested or absorbed. Venom is injected via fangs or stingers. And a lot of people don't know there's another vocabulary word, toxungan, that is delivered to the body surface without a wound, like spitting cobras, for example. There's a bunch of scorpions that do that. If the delivery method is, spraying it on the prey or spraying it as a defense mechanism, and it has an effect, like there's a lot of venoms or poisons that could get on your skin that aren't necessarily going to cause a bad reaction, but I mean, you could end up without your eyesight, at least for temporarily, if not forever, if you end up getting some of these toxins in your eyes. So anyway, the next time you run across a know-it-all that's correcting people about poisonous versus venomous, in the past we were able to correct them by saying some or both, but you can also next level force up correct them by saying, there's also toxins. Uh, if there's anybody that doesn't know it, uh, there are animals that are both, like the tiger keelback, but there's also less known ones that are both for different reasons. Like the keelback sequesters toxins that, if it was eaten, would then be poisonous. But I mean, you can see that as a specific, understandable defense mechanism. But there's populations, for example, of garter snakes here in the US that have been studied that have such high levels of mercury in them, as high or higher than the fish that you see warnings about if you ever read fishing regulations, they come with how the maximum that either people should eat in a year or that pregnant women should eat because of the mercury levels in the water that are then, absorbed into the fish and then eaten by you. And there's a certain level of it that we don't think affects us, but you should be careful about going over that. So it's not just fish, is my point. There's, garter snakes eat the fish. So this stuff is happening to them. They don't have regulations that they follow. They're going to eat as many of those fish as they can. And so it's at the amount where it would be technically considered poisonous to us. More than technically. I mean, if you were in the habit of eating these garter snakes, you could have problems. But it's not like something that they're doing, and it's not necessarily even something that's inherent or purposeful from their, physiology. It's the same thing that would happen to us if we were eating a bunch of fish with mercury in them. I just like to point that out, not only because it's fun information, but there are more facets than we previously knew going on here. And it's just a great reminder to me about there being more to learn than we know. Anytime that folks seem like they already know the answer, oh, the poisonous is when you bite it and you die, and venomous is when it bites you and you die. That's not close to knowing it all. That's just a little tidbit. There's so many layers and fascinating stuff to look into just in this one slide alone. But we don't have time to spend all day on it. I'm just encouraging you to look into this stuff more because there's more to it than we, I think, are often to hear online. Moving on. One more thing I will say about that. We don't have to scroll back, but that's why I don't allow that stuff in my groups, because it's pointless. It's often rude. It's just somebody, I won't say just, but so often it's someone jumping on the chance to feel superior by correcting somebody else. You know what I'm getting at. And rudeness is the big thing that we don't allow in my groups. And so this falls under that category. Even if you weren't trying to be rude, the comment's probably going to get deleted because we have to enforce things fairly for that reason. So fangs, gosh, there's so much more to talk about fangs, but we just don't have time today. But I thought I'd at least give you a diagram real quick for those that don't understand. You've got your venom duct that goes between the venom gland and the fangs. You've got a compressor muscle. That's what operates the venom duct. So like the way that you would decorate a cake, if you're squeezing the, cake funnel, is the way that the pressure is generated and how the whole mechanism works. And then you've got, a venom canal either in the teeth or with, like the rear fang. Some other species, you've got it like Heloderma, the beaded lizards and Gila monsters and stuff. They don't actually. You'd be hard pressed to call those fangs, but it's a similar mechanism. They don't have a canal that goes inside the tooth. They have some grooves in their teeth that their venom, flows down and gets into a wound as they're biting the skin of an animal, or an idiot person that picks them up and causes them to get bit. But this diagram isn't the way all fangs are. Fangs have a lot of variety, just like everything else we want to talk about reptiles. But, this is the general idea at any rate. But I'll see if I can remember. If you want it, remind me. I can link you to a great, great, great article, like the one article everybody should read if you want to know more about fangs. But it's more than we can cover here today, so we're going to move on. Rear fang snakes. This is a great picture. It really shows if you look, somewhat closely. You don't have to take a magnifying glass. You can see those rear fangs. They're noticeable and prominent. And you can see that, for like this hognose that likes to eat toads, if you hadn't already observed it happening in the wild, toads will inflate to try and get to be too big to swallow, at least for, a snake that's small enough. And those fangs not only can deliver that venom, but they can also oftentimes puncture those air sacs that cause them to inflate. So it's a good example of the arms race that goes on between predator and prey in nature. One animal will develop a mechanism to keep from getting eaten, and then another animal will develop a mechanism to bypass that and eat them anyway, and then the other animal will develop some kind of mechanism against this new mechanism, and it just goes on and on and on. And interesting to see an example of that happening so clearly like this. Now, animals like this, these rear fang, there are rear fang snakes that have enough venom to cause reactions in people, but generally those reactions are not enough to send you to the hospital, or like you might want to go to urgent care and they might be able to do something for you, but it's not something that they produce anti-venom for. It's not generally life-threatening. Hognoses can, if you let them chew on you, and this is how it happens. Let me mention with hognoses, to my knowledge, still to this day, there's never been a recorded bite of somebody getting bitten by a hognose in the wild and experiencing anything from that. In fact, I don't know anybody that's been bitten by one at all in the wild. You can put your finger in their mouth, and they don't bite you. But that's not the case with captives. Captives, bless their heart, I'm sure we've all seen the pictures of them biting their food bowl and biting a piece of bread or biting whatever you put near them, because they just, bless their hearts, don't come off as that bright. But they'll do that with you also. You could be sitting with them, and if you're watching TV and with them in your lap or something, they're just chilling, they might, investigate your finger and start, putting their mouth around your finger. And if you're a keeper that thinks, oh gosh, look how cute that is, a big dummy, and you let them sit there for a while biting you, eventually you're going to have enough of this venom, quite likely, delivered, that you're going to have a reaction. And sometimes when you hear people talk about that, what frequently happens is somebody say that they're harmless. It's just, you're just allergic. No, I mean, yes, it's possible to be allergic, but the numbness, sometimes pain, sometimes, other sensations that can last, depending on how long the bite happened, from a few hours to a few days even. That's not an allergic reaction typically. That's your body reacting to the venom. The venom is an adverse compound, and your body is having to process it to get rid of it. Just because they're not sending you to the hospital, the choice isn't between venomous that sent you to the hospital or you're just having an allergic reaction. I hear that a lot. Probably y'all have too. I like to be very clear that it's not an either or. That's a false dichotomy. There's a spectrum in the middle, and if you're getting venom injected into you and you're having a reaction, that's because venom is supposed to do unpleasant things. That's the point of venom. That may not be enough to kill you, but it doesn't just mean that you have an allergy. So anyway, we covered that. Moving on a bit. How far are we? 119. We can pick the farther. Gosh, gecko feet. Here's something, another fascinating thing. So, excuse me. Those little structures on their feet, called setae and spatulae as you get smaller. First off, if you've never seen this picture before, it's fascinating just by itself. Seeing how the setae and spatulae divide and further divide into a nanostructure that even in this photo at 1 micrometer, there's still too many to count just in that picture alone. So, wow, that's wild. And as we discovered this and started asking why, uh, one theory was that those get so small that they're able to fit into microstructures and grip like that, sort of like cleats, on the ground. But no, as we learn more, they use what's called van der Waals forces, which is this sort of weak electromagnetic, sort of static electricity type of interaction where they stick to what they're up against with this essentially magnetic type force. And each little tiny end of each thing that you see there has that going on. So when it's multiplied by this many, that's why you end up with, geckos that can hang from one toe off of something. Now they can have, with captives, they could just be caught in the screen, but they can literally also do that in the wild. And so when the scientists studying them started realizing that these forces were at play and how much of these forces, multiplied across all these surfaces was interacting with the surfaces, they began smartly to ask, well, gosh, how can they pick their foot back up after they do this? And they realized it's kind of like, well, my way of putting it is like a piece of tape on glass. If you were to put a 2-inch piece of painter's tape, across your bathroom mirror, and if there was a way that you were able to grip it and pull it off all at once, you wouldn't be able to do it because there's too much, adhesive force there. But if you start from one side, it's super easy to peel it off. Well, they do the same thing with their foot. As they, put their foot down, those forces start interacting. It's too strong for them to just lift their foot straight up. So you'll notice sometimes it's a little too subtle to easily notice, but they roll their feet off the same way you would roll that piece of tape off. Uh, and studying them is, I mean, they're trying to come up with Spider-Man type gloves and these different things. But if utilizing these van der Waals forces, if we can harness these forces in a meaningful way for products and innovations, there's no end to the types of things we could do with it. So you can be sure that there's scientists that are going to keep studying them very closely for a while. But anyway, hope I made you a little more fascinated with gecko feet. Moving on. Forked tongues. Okay, so I say we all, most of y'all that are regulars in my groups know stuff like this, but we're going to mention it anyway. Their tongues are essentially for it. When I say they, I'm talking about certain lizards and snakes, uh, the ones that have forked tongues. It's for, smelling the air essentially. When they flick their tongue, not only does that sample the air more than just sticking their tongue out and back, because it's touching more air, but also they create these little vortices, these little circles of air. So they're multiplying how much air they're tasting, that they're coming in contact with, in that small amount of space when they do it. And they bring it back into their mouth, and it's that go touches what's called, you either hear it the Jacobson's organ, or the more technical term is vomeronasal organ. Either way, there's an organ in the roof of their mouth connected to their brain. Their brain deciphers the stuff, and it's a sensitive enough mechanism that they appear to be able to tell which side is stronger. Like when you hear somebody's voice stronger in this ear, than this ear, you can tell what direction they're coming from. They can use that a similar type of directionality to figure out where the prey animal, for example, is from that they're stalking. So there's a lot going on there. It's not just a forked tongue. It's these fascinating, interesting layers of stuff going on. So moving on, we got scales. Another one I'm not going to spend all day with, but I could. Suffice it to say that there's a lot of variation in different scales on different reptiles. I think we all know that. But in particular, when you're trying to ID a reptile, pay close attention to keeled scales. If you look closely at this cottonmouth, third from the left, you can see what looks like the bottom of a boat, ergo the name keeled scales. Uh, and as you can imagine, those increase your ability to swim through water. You've got that extra, not really gripping surface, but friction surface to give you some more traction in a liquid environment that doesn't lend itself well to that. But besides that being an example of the different function of the different sizes, keels are very useful in arriving at an ID with a lot of animals. Like king snakes have very smooth, shiny scales. Going back to the taxonomy, uh, their Lampropeltis means shiny shield. The lamp, like a light, shiny. Peltis, like pelts. They used to make shields out of pelts uh, because of how glossy and shiny their scales are. So if you're looking at a field guide, rat snakes, for example, they have weakly keeled scales along their dorsal line, their spine, close to the middle of their back, and smoother scales, just smooth scales, the further away you get from that, which is different than a king snake or a racer or some of these other animals. So if you're not at the point yet of being able to easily tell the head shape or eye shape or some of these other things that are can seem like really minute differences to a novice, it may be easier to be able to look at the keeled scales, and that will give you a good way to rule out a bunch of organisms that way. So, as fascinating as they are, we're going to move past those so we can keep making progress. Toxic toads. So, toads, specifically Bufo and Anaxarus. The toads here in the U.S. used to also be called Bufo, the genus, the name of the scientific name of a group of toads. But we've divided them, and now Bufo is considered old world toads, meaning Eastern Hemisphere, and ours that were Bufo are now Anaxarus. Boring taxonomy bit, but the point is, I have to make that differentiation because there's a lot of other things we call toads, like narrow-mouth toads and so forth, that are not associated with these parotid glands. Anyway, they're poisonous because they can excrete a toxin, and there's a picture of it here if you've never seen it before, of that toxin coming out of the gland. And not only can that deter predators, but it's the shape of those glands is very useful. It can be hard to ID toads. I have a hard time IDing toads that aren't the kinds that I'm already familiar with in my local area. But the shape of those parotid glands is another useful ID thing to hone in on. Funny story, my grandparents used to have a Yorkshire Terrier named Nick, and they would let him out in the backyard, and there came a time when he would come back in and he's like experiencing ataxia, not being able to walk straight, listing to one side, and not exactly foaming at the mouth, but drooling a lot and, acting kind of dazed. And my grandparents were super worried about him, but it faded out, and they thought, maybe they'll bring him to the vet, but, it was late and they didn't. And then he seemed fine, so he put it off, and then he came back in, not during the day, but when they let him out a little bit after dark or something, and he'd come back in and he was doing it again. And this happened a few times, and my grandfather finally managed to follow him and watch him closely enough that he figured out that he was figuring out where the local toads were in the yard, and he was going over there and harassing them and then licking them to get high. And my mom grew up in Conway, Arkansas, right across the river from a place called Toadsuck, Arkansas, because people are known for doing the same thing. I don't recommend it. In fact, I strongly advise you don't upset toads, make them excrete bufotoxin, and then lick the bufotoxin off of them. However, if you do insist on doing it, please upload it to YouTube and message me a link, because I know some people that would love to watch that video. But please don't do it regardless. Nobody's going to pay you to do it. And in fact, we're probably going to think less of you. But nonetheless, I do still want the video if you just can't resist. So That's my own personal joke. My strange sense of humor should not reflect the official positions of Happy Dragons or the Herpetology Collective, etc. Anyway, guys and gals, and other, when is a frog a toad? Okay, so this is a tricky one. It's true, in my opinion, to say that all toads are frogs, but not all frogs are toads. And honestly, you can just leave it at that if you want. In my opinion, and the opinion of other biologists that I know, there's not a clear delineating thing that you can point to that says these are frogs and these are toads. You know, you've got so many animals that are called toads that are that display such a wide spectrum, and sometimes you'd almost have to chalk it up to that's just a common name that stuck because you can't really see why they would be called toads otherwise. Uh, but then I've seen other biologists, or at least young biologists online, try to make a list of here's what are frogs and here's what are toads. But the times that I've seen that happen, you know, there's exceptions. And so it's just muddy. To me, it's kind of like calling where's the difference between a shrub and a tree? You know, there's not, you know, you go out there with a yardstick, and if it's more than 4 foot tall, it's a tree. And if it's shorter than that, it's a shrub. I mean, it's just kind of the names that we give them. Nonetheless, typically, when people talk about toads, they're talking about frogs that have more tubercles on their skin and that can get really dry, you know, dry to the touch without ill effect. Whereas a lot of frogs, you know, if they end up completely dry, they're going to desiccate and they can't live very long. I think a lot of us may have found dried up tree frogs in our house and things like that. You know, a lot of frogs have to be around that moisture to keep their skin moist for that cutaneous respiration we were talking about. Whereas frogs have a much higher tolerance to getting dry and, you know, being even in desert environments and stuff. I think I said toads. You know what I mean. Either way. So mating behavior, another thing about toads, just since we're talking about toads, these are some pictures I took. On the left, that is called amplexus. Not all mating grasps are called amplexus. That specific mating grasp is because they're reaching under the, hopefully females, armpits. That's how it got its name. But there's actually a bunch of different, you know, from butt to butt to, you know, I think I saw a diagram of at least a dozen, you know, a while back, different mating positions for frogs. So I think a lot of people think that amplexus means a frog's mating grasp, but it actually is one of many. And then the other picture is a male on top of another male, which is very common. I think we've all seen pictures of the cane toad on the python, which is an unfortunate, you know, side quest talking about invasive species and so forth. But the point is, it's so common among toads to jump on anything that moves that we've found that the males actually have a specific chirp called a release chirp that basically translates to "get off me, dummy, I'm a male." uh, and I just think that's humorous that you've got a species that's so randy that they've had to develop, you know, language for it amongst themselves. So skipping on, it's an example of just how non-discriminatory they can be. I just put that in for some more levity. So moving on. All right, differences in eggs. I know we're at an hour and a half point right now. I apologize. Drank a bunch of tea on the way here. I got to hit the head for a minute. Y'all can do the same if you want, or I think you know, my director in the background is going to check the notes on here for questions and stuff and keep y'all entertained for a minute. But in any event, pardon me. I'll be back in 90 seconds to 2 minutes.
Bad news for me, the refuge is closed, so I'm going to have to put on my big boy britches and suck it up. So, differences in eggs is where we were. Amniotic versus anamniotic are scientific terms that a lot of people aren't familiar with. What that means is possessing an amniote or not possessing an amniote. You might can extract, if you're not familiar with that, from the root word that humans are amniotic. That you may have heard the term amniocentesis. That's pregnant women are familiar with. Uh, what that is an extra structure inside the egg that causes nutrient exchange to happen differently. In anamniotic eggs, meaning eggs that don't contain an amniote, examples of which are frogs and salamanders, the gelatinous mass rather than hard shelled clutches. The gas exchange happens through all of those layers with the surrounding atmosphere and so forth. With the amniotic eggs, you've got a yolk and uh, what's called, um, well, you've got the amnion that surrounds the fetus, the organism, the developing organism in there. You've got the yolk sac, and then you've got nutrient exchange happening through the amnion, and it's all happening inside the egg. The reason why this is important from a survival and evolutionary perspective is somewhat obviously that hard shelled eggs, amniotic eggs, can be laid away from water because they're not so dependent on that moisture to keep the gelatinous structure hydrated. So the development of this in animals allowed animals to colonize dry areas. If everything was still anamniotic as a reproductive method, we would only have wetland and water-based organisms. So that little bit of difference that I think a lot of us haven't spent much time talking about is one key, super important foundational difference to the entire world around us and the organisms as we know it. So I always make sure and highlight that term because I think it's a good thing to stop and realize for a minute. But moving on, we have some examples of these different eggs. These are, hard-shelled eggs I think that we're familiar with. And you can see on the turtle the remnant of that connection to the yolk um, in the lower right-hand corner I'm talking about. In humans, you've got the umbilical cord that gets cut and tied. It's same type of stuff. That's not present in anamniotic eggs, which we have an example of moving forward, I believe. I guess I took it out or don't have it yet. Oh, because we're honing in on reptile reproduction. That's right. So you've got different methods. Oftentimes you hear people talking about oviparous, meaning egg laying, viviparous, meaning live bearing, or ovoviviparous. But honestly, that's a piece of technical jargon that's fallen by the wayside because the more that we study these animals, the more that what we were calling ovoviviparous is really just viviparous because the differences that we were pointing to are really just a part of a spectrum rather than, hey, here's a delineating line and, here's the ones on this side of it and this side of it, because the nutrient exchange and everything else is still happening with the ones we were calling ovoviviparous essentially the same way they happen with any other viviparous ones. So there's a little debate you may not have been aware of, but if you hear people going into great length about how ovoviviparous is different, just let them go. You don't need to try and memorize all that because it's largely been superseded in current scientific thinking. Reptiles' ability to lay hard shell eggs, like I said, enable them to colonize virtually every plant on Earth, not nearly depend on water, and they have a lot of different ways that they give birth. The green anaconda gives birth in water. Pig-nosed turtles, if you don't know, are an example of turtles that the clutch gets laid, and it can sit there for a long, long time. And where those turtles live has, monsoon seasonal floods, and when the water floods the nest, boom, those turtles hatch and start swimming. And that's an interesting little survival technique because it cuts out the chances of them getting eaten between the nest and getting to the water. And it also, eliminates the chances of them hatching at a time during a dry spell and not being able to get to water. So it's a interesting way of solving some problems that some of these turtles have developed. Moving on. Sex determination. So in reptiles, a lot of us probably know that there's TSD and GSD. TSD is temperature dependent sex determinations, which means that the sex is determined at a crucial period in development based on the ambient temperatures that it's existing in. For example, higher temps meaning males, lower temps meaning females, and a small median area where you can get a mix of both. So that's as opposed to genotypic sex determination, which is also common in the animal world. Humans exhibit genotypic sex determination, where the uh, sex is determined genetically depending on the chromosomes and so forth. Uh, Interestingly, some reptiles exhibit a mixture of the two, and some appear to be able to switch back and forth between the two depending on their environment. You can imagine if temperature dependent sex determination is the method by which a species reproduces, and you experience climate changes, which is not something unique to the world we live in now. It always happens throughout time. Things change. You would end up with extinctions just for that reason alone, because if all of the eggs, for example, were only hatching male, that would be the end of that line of critters. Uh, and that sure that happens sometimes, but since that's a thing that happens predictably, some animals have shown to be able to survive anyway by switching to genotypic sex determination. And to me, the fact that they can do that is amazing. Uh, the tricks like this that reptiles exhibit and their ability to adapt and survive is admirable. It's fascinating is the best word for it. This type of stuff is why I say somebody that's paying attention can never get bored with reptiles and amphibians, because at first glance, TSD versus GSD just sounds like a boring topic that your biology teacher might be trying to tell you is going to be on a test to some of our thinking when you're not used to digging into the science. But when you stop and realize what this stuff means, and like this ability to change between the two, how it is the difference between a species still being on the planet and having gone extinct and been gone, and how wild and odd seeming it is to even have that ability to change. I'm probably sounding like I'm just, and I am just nerding out at the moment, but I'm encouraging you to, when you learn these things that just sound like scientific facts, to kind of take a moment and let the ramifications hit you of what all these things mean from a survival perspective. Uh, it can really open up a whole new world if it's not a world you're already immersed in, of learning and being, interested in and fascinated by, and ultimately, I hope, wanting to protect and defend these animals in the wild. So, moving on, parthenogenesis. You often hear that referred to as virgin birth. I got quotations and marks around that because it doesn't actually matter if the female is a virgin. She could have mated before and had eggs before. The point is giving birth or laying a fertile clutch without mating. Another thing I see mixed up is people thinking that every time their beardy or whatever lays some eggs, that's parthenogenesis because they went with the male. No, parthenogenesis is specifically fertile eggs, uh, or fertile live born young without mating. So we know of at least 8 lizard families and 1 snake family, over 50 species in all, that have been documented to do this, including the Komodo dragon, copperheads, and cottonmouths. There are a lot of people that know about parthenogenesis think of whiptail lizards, because they're been well studied, so they're kind of famous for it, particularly the desert grassland whiptail lizard, because they're all female. And I've got a picture there of mourning geckos, another example, all female species.
because that's how they routinely reproduce is through parthenogenesis. But I like to point out that this may be more prevalent than we know. Like, I mean, obviously, in a wild critter, when they give birth or lay eggs, you don't know whether that animal is mated or whether or not it's parthenogenetic unless you have been following her every moment of the day or you do DNA sequencing. So it's very, very easy to think that this is quite a bit more common than we realize. Uh, and that's an interesting topic I could go on about, but let's move on. All right, so that was the reptile side. This is the anamniotic, amphibian side. Here's what some of these egg masses look like, and so forth. And there's an example of a salamander, which a lot of them do, brooding their clutch, and some of them will brood even more clutches than their own in a communal laying site, which demonstrates a maternal care level of maternal care that a lot of people don't associate with reptiles, but is actually a lot more common than a lot of people think. Uh, Alligators do it. Five-line skinks do it. I could go on, but moving on. I think we're all familiar with the concept of these gelatinous eggs, and I think we can skip by this. I'm going to assume that everybody listening has heard of a frog life cycle. I will point out that with the salamander life cycle, it's a little different than the frog life cycle, particularly with newts. Newts have a period of time where they become terrestrial, during which time they're called an eft, E-F-T. Those are the times when people typically see them. Like if you see somebody taking a picture of a newt, it's during that eft stage when they're terrestrial. But unlike other salamanders, that's not the rest of their life. They then switch back to being aquatic after that period of time. And I'll say that there are species like the axolotl that never have a terrestrial stage. Usually they can. Uh, and that trait is called neoteny. Those are referred to as neotenic species. And that means that they retain their juvenile form throughout their life. Moving on. All right, so we're not going to go deep into turtle shells, but I will just mention the broad strokes of that pertain to ID. The top of the turtle shell is a carapace, the bottom is a plastron. The little scutes on the side that connect the two is called a bridge. And then the carapace and plastron are further divided into the names for the different kinds and locations of scutes that you find on them. On the back, it's costal, marginal, nuchal, and vertebral, with a diagram there of which is which. And then similarly, with the plastron, you've got gular, humeral, pectoral, marginal, abdominal, femoral, and anal. And if you're not a turtle geek and you're never going to talk to anybody about how you ID'd this species versus another, like for example, differentiating a mud turtle from a stink pot musk turtle, you can do that without picking them up if you're really familiar, but the easiest way to do it is pick them up and you see the difference in the gular scutes and whether or not the seam connects to the rear seam of the humeral scutes. There are differences in the way that these scutes fit together that make IDs, even sometimes for tricky to ID species, obvious. So if you take a minute to pay attention to those different names and therefore locations and shapes and so forth, it can make learning about them and IDing them a lot easier. So take a minute to learn the names, maybe, if you want to be a turtle geek. Moving on. All right, snakes and swallowing. I think a lot of us know, but the general public doesn't generally know that snakes' jaws are connected by elastic ligaments, that they don't dislocate their teeth. There's no socket that's put together that's pulled apart, which would be what dislocation is. They're stretchy, basically, elastic ligaments. So this is what allows them to swallow large prey, and while they're doing so, their glottis extends out of their mouth. You can see it in this picture here if you look closely, the little pink circle-ish thing on the left side. And and that's how they continue breathing even when their mouth and what appears to be their whole throat and everything is full that would be choking them otherwise. Uh, so we'll move on. All right, so a lot of people think of serpentine motion when they think of snakes, and that being quote unquote how snakes move. But snakes have a lot of different ways of moving, and the four most common, in my opinion, are these here, which the top one is concertina, which is kind of like an accordion or whatever, where the one part comes together and the next part moves and then comes together and moves. Uh, you got serpentine, which is the wiggly snake dance that a lot of people think of. You've got sidewinding, which a lot of people have heard of, but it's definitely its own distinct mechanism. And then you've got rectilinear, which some people call caterpillar. You may have seen some viral videos going around of Bitis species, or a lot of different snakes can do it, where they go in a straight line and they do that, kind of the same way as caterpillar, which is why that's called that sometimes, moves forward by their belly scales. They alternate the muscles as they're moving, and that uses the belly scales to grip, which the benefit of that is if you're sneaking up on something and you're moving back and forth, it's really easy to get spotted from a distance and lose that feeding opportunity. But if you can just look like a stick that doesn't even look like it's moving unless you're watching closely, you have a much better chance of getting up close to that prey animal. So, moving on again. All right, hibernation and estivation. It's a state of slowed metabolism, not an extended sleep. This I wouldn't really exactly call a pet peeve, but another one of these technical discussions real quick. Often people refer to reptiles hibernating as brumation. That's not exactly wrong, but it's also not entirely right. There's a lot of scientists that I think rightfully feel like it's unnecessary jargon, because when you give a name to something like that, what you're implying is that there is a difference that sets these animals that do this over here apart from these animals that do something different over here. But reptile and amphibian hibernation methods, again, happen along a spectrum, like we were talking about with the ovovivipar's births. And the more we study them, the more that's reinforced. There's not like these animals over here do it this way and reptiles over here do it this way. There's a lot of reptiles that hibernate more like monotremes than they do, I'm not going to geek out on it too much, but the point is, there's a lot of scientists that believe that that's unnecessary jargon that popped up before we knew as much as we know now, and it's not really necessary or even all that helpful to keep it alive at this point. But I don't argue with people because it's the accepted term. There's still a lot of herpetologists or biologists that use it just kind of out of habit, but you're not going to find me using it, and that's why. So during this period of hibernation, or whatever you want to call it, the body burns fewer calories and uses less oxygen, since they don't need to be generating internal heat to keep them at a certain temperature like us mammals during cold weather. They can just tone everything down. They end up using a lot less energy, so they don't typically need to eat. It's actually not advisable for a lot of reptiles and stuff to eat, because since they can't warm up to properly digest, the food can, decompose and kill them. Which is why we say to the people that find a lizard in their house or something, don't feed it before you let it outside, a wild animal I'm talking about, because you could be seriously messing it up. But you get him warm and he thinks he can eat, and then you dump him out in the cold and he's got no way to digest it. That's a problem. So aquatic turtles are able to, since they're toning everything down so much, get by even frozen under the ice in the winter underwater, because since they only need a tiny bit of oxygen, they're able to absorb that through the vascular tissues inside their cloaca. They take the water in through that opening in their tail, and essentially their colon, the respiration happens there, sort of like fish are able to get the oxygen out of water. Turtles' butts can too. I think a lot of y'all have heard that, but that's kind of the mechanism. So it's not just that they sleep for months. They can be periodically active. You'll notice on warm days, the lizards coming out and looking for a drink sometimes, or getting in the sun and seeing how much they can warm up. And then conversely, during times of high temperatures, a lot of reptile species estivate, which is another state of reduced activity that keeps them from fatally overheating. Down south, and even in hotter climes, you see this more. Animal will become torpid, listless. That's a survival mechanism that keeps them from overheating. So, moving on. All right, so that's the end of another segment. We got questions, comments. Let me stop and check them here. Another good comment from the caffeinated lizard. Don't lick toads and frogs. It's an oddly unsurprising phrase I've had to say out loud to real life people. Okay, here's an I don't know the answer to question. Aside from being able to find a new body of water without issue, is there any particular reason that newts have that terrestrial stage? I think that any answer to that is a hypothesis, and I think that the hypothesis you put forth is a good one. And I haven't spent enough time really digging into it to have any alternate hypotheses, no. And Carrie, I see you're paying attention there. So, lots of good comments, not a whole lot of questions. Sounds good. Boy, this thing about the refuge being closed is kind of hitting me. You know what I'm going to do? I hope it's not a disappointment, but we're at the 2-hour mark, and that happened to fall exactly at a break in segments here. So I am going to turn part 3 moving forward into the next webinar, and I'm going to give y'all another chance for comments and questions and go find a bathroom, if I'm being just entirely honest. Please, I want to improve what I do, my educational delivery and so forth, either in the comments here or send me a message on Facebook or whatever. If you're willing to, I would certainly appreciate it. Let me know. I mean, was I moving too fast? Was I moving too slow? Am I spending a little bit too much time on the technical end? Am I spending enough time on the technical end? I don't care what it is. Anything that you can give me that would help me improve, bear the stuff in mind, and deliver webinars that y'all want to tune into better is what I want to do. So, hey, I got one for you. If you don't want to sound critical to my face, but you do have some thoughts, I'm trying to remember which groups allow anonymous posts. I know that Riding the Struggle Bus allows anonymous posts, if you remember there. I will see if Herpetology does. But anyway, my point was you could submit an anonymous post in one of my groups that allows it, and then, oh no, that won't work because I'm an admin and I can see who it is, I think. Anyway, just have the courage of your convictions, and if I'm off on something, if there's something I can improve, just go ahead and message me and let me know. You're not offending me. I appreciate it. And, back again to the Happy Dragons. I have been putting work into this for a while because it's an all-star cast. It's people that care. Every time we've had any conversation about anything, we're all on the same page. We're all about science. We're all about the welfare of the animals. We're all about only wanting to deal with and promote people that are conducting their businesses ethically. Just every aspect of everything that I've come across with this initiative, I respect and appreciate. And I've never found that before. I'm going to be 50 soon. I've been into reptiles all my life and around the reptile community. And I'm not trying to bash the entire reptile community. I'm just saying that I personally have never found a group of people that not only care as much as everybody with Happy Dragons does, but has their head on straight, so to speak. The business model, the things I see people complaining about corporations and businesses and stuff are just not happening there. Everything is about finding people's niche having people do what they're good at and not sit and force them to do the stuff that they're not good at. We'll find somebody else, or hire a vendor or something to do that stuff that you're not good at. Just everything about it is great, and we are committed to adding more value and depth to the platform and to the shop and to everything for you guys. We have, like I say, those care plans that go a year out, that are tailored specifically to you and your situation. It's not a cookie cutter sort of thing. Here's, just click here. It's a care plan for you. We're working on getting these peer groups set up to where, I don't want to give it all away or lock us into something, because, things evolve as we get into them and develop them. But uh, the point is, have a team that, of peers that you not necessarily are working together with, but gosh, I don't want to give away everything ahead of time, because it all evolves. But there's so many exciting initiatives that are on the table, and we've prioritized developing them according to what y'all have told us. These polls and stuff that we've been doing, where y'all tell us what your highest priorities are. Those are the things we've made our highest priorities. And as we get those up and running, we've got more things in the wings that we're going to keep working on. And this is something that's going to be around for a while. And if you can come over and appreciate a lot of content and a lot of stuff like this is streaming on YouTube without being a $9 a month subscriber on Patreon. But and that was one thing that we committed to amongst ourselves, that we're not going to keep any life-saving information from anybody because they're not paying. We're going to make sure that stuff like that's going to help the animals, that's going to be critical, that people need to know, is always going to be available to everybody. But when it comes obviously to having experts take time out of their day to cater things custom to you, it's exciting to have that resource. But it does take time, and there's you know that's how you create the space to have that time, is by having some sort of income stream. And again, there's so many reasons why the Patreon is justified. One is that you're helping, rescued animals. Another is that, if you use the shop at all, you're going to get that money back in discounts right away. Some of it might just be to show your support, so we can know that we're on the right track by doing all this stuff. But this webinar is just the beginning. We've got, like I showed you earlier, the next several weeks all planned out, and we've got more ready to get put in the chute after that. And these webinars are just one little part of everything that's going on at Happy Dragons. So like the page on Facebook, Happy Dragons, so that you can follow the stuff that we post on there. Try and pay attention in Herpetology, because like I say, we're focused on the Herpetology community, because it's a large family friendly collection of reptile keepers, and we know that a lot of people there are also people that care. We know a lot of people there have learned that a lot of the information available on social media and on the internet about reptile husbandry is what I was referring to as folklore. And when it comes time for somebody to want to buy an animal, a lot of people that care, start asking, well, how do I know who to buy from? And we've got the answer for that. These folks are the ones that we've already verified operate to this high ethical standard. So I could go on, but if nothing else, it's an alternative to Facebook. I don't know if y'all's experience has been like mine, but Facebook has turned my feed into, ads and posts from pages of people I've never even heard of. A lot of it's stuff I'm not even interested in. And it seems to be going downhill. Pretty quickly, the quality, if you can call it that in the first place. And we've been there because that's where the people are, if you're anything like me. But now we've got an alternative. We've got a Discord server you can come over to right now, whether or not you're a subscriber. Join up, start, pitching in, talking, ask questions. You can post your memes. We've got different forums. You just find the appropriate forum for the discussion you're wanting to have. And we'd love to have y'all. I'd love to see thousands of people on there, right away. And having a positive, encouraging, science-based, ethically focused reptile platform. that's been the dream for a lot of people for a long time, and it's, as far as I know, has never manifested until now. But it's here now. It's just starting out, so when you go there, there's not going to be a whole lot of, posts in the forums and stuff. But you're the ground crew, and furthermore, I'll mention that we have a commitment that the founding members, meaning y'all, the people that sign up now to be the Patreon subscribers, are going to have that price locked in. So, a few years down the road, when $9 is only worth half of what it is now, that's all y'all are ever going to have to pay if you stay subscribers. Uh, just there's some other perks too, but there are benefits to getting in while it's young and new like this, even though there's not going to be as much depth to the forum as there will be in the future when there's more folks around. So what you were listening to today is an example of this new platform, and it's not all of it. It's just a tiny little part of it. I hope y'all all look into it and come and see more. And I don't see a whole lot of new questions, so I'm going to sign off. And I've never done a webinar before, so I guess I'm going to do it with my signature tagline of Happy Herping. Hope to see y'all all again soon.